All right, let's talk about the holy grail of shipping software, zero-downtime deploys. It's what we all want, right? Well, today, we're going to dig into how some of the most reliable, rock-solid methods for getting there are actually, well, they're decades old.
You know, for the last few years, if you ask, how do I get zero downtime? The answer you'll almost always hear is just one word: Kubernetes. It's become the go-to solution for everything. But is it always the right tool for the job? Or is it sometimes like using a sledgehammer to crack a nut?
And to be fair, you can totally see why it's so popular. I mean, Kubernetes makes this whole complicated process feel incredibly simple. It kind of hides all the messy details and lets you roll out a new version, keep the old one running, and then just seamlessly shuffle traffic over. It feels amazing, it feels powerful, and that's a huge, huge draw.
But here's the thing, that convenience comes with a price tag. The Kubernetes path brings a ton of complexity, a really significant cognitive tax. And that's not just about learning at once. It's the mountain of YAML files, the constant maintenance, and the steep learning curve for every single person who joins your team. On the other hand, what we're calling the ancient path, it has way fewer moving parts, it's simple, it's predictable, and honestly, it's often shockingly effective.
So let's blow the dust off the old playbook, shall we? Let's rediscover these classic, time-tested strategies that engineers were using to ship code flawlessly long before platforms like Kubernetes were even a glimmer in someone's eye. You know, if you ask a seasoned engineer, someone who's been in the trenches for a while, how to solve this, you'll probably get a really simple answer. Run at least 2 servers, stick a load balancer in front of them, and just update them one at a time. It's not flashy, it's not the new hotness, but it is an absolutely bulletproof method that just works.
And that simple idea leads us to one of the most famous patterns out there, the blue-green deployment. It's so simple and brilliant. You've got your current stable version, we'll call it blue, handling all your live users. Then you deploy the new version to a totally separate but identical environment. We'll call that one green. Once you've tested green and you're 100% sure it's good to go, you just flip a switch at the load balancer, and boom, all traffic is now hitting the green environment. If something goes wrong, no sweat, you just flip the switch right back to blue. It's literally like switching the HDMI input on your TV.
Okay, next up is a real classic from the old Unix days, the symlinks switch. Here's how it works. You upload your new code into its own new folder. Now you have a special file called a symlink. You can just think of it like a shortcut. And that shortcut is named current, and it points to the folder with the live code. When you want to deploy, all you do is change where that shortcut points. You make it point to the new folder. And because changing a symlink is an atomic, instantaneous operation on the file system, the switch is flawless and immediate.
Now, some people see this and think, hey, couldn't I just do the same thing by changing a DNS record? And the answer is, technically yes, but please, please don't. It's a really risky game. A load balancer gives you that instant, predictable cutover you need. DNS, on the other hand, is at the mercy of caching all across the internet. That means a DNS flip might take seconds for one user and literally hours for another. It's just way too chaotic and unpredictable for professional deployment.
So we've seen a couple of solid methods now, but there's this single unifying principle that makes all of them work. This, right here, is the secret sauce that actually enables true zero-downtime deployments.
So before I just tell you, what do you think it is? What is the one thing that your application absolutely has to be able to do to make sure these smooth transitions happen without dropping a single user's connection?
The answer is one little thing called SIGTERM. This is it. This is the linchpin, the magic signal that unlocks everything we've been talking about.
So what the heck is SIGTERM? Well, the most important thing to understand is that it's not a command to die now. It's more like a polite request, a little tap on the shoulder saying, hey, could you please finish what you're doing and then shut down when you're ready? When your app gets a SIGTERM signal, it should stop taking any new connections. But, and this is the crucial part, it lets all the existing active connections finish their work. This is what ensures that nobody's request gets cut off midstream during a deploy.
And what's so fascinating about all this is that if you're using modern cloud platforms today, you're actually already using these old tricks. They're just packaged up with a nice, shiny new name for you. Just take a look. When you use staging slots in Azure App Service, what you're really doing is a managed blue-green deployment. When you create new revisions in Google Cloud Run or do rolling updates in AWS ECS, you're just using an automated version of that classic load balancer method. The big cloud providers literally built entire services on top of these fundamental time-tested ideas.
This all applies to containers too. A lot of people hear Docker and they immediately think Kubernetes, but that's just not the case.
You can get all the amazing benefits of zero-downtime deploys with way simpler tools, like using Docker Compose with a smart reverse proxy like Traffic to handle all the health checks and traffic routing for you. You're really just applying that same old two servers logic, but to containers instead.
Okay, so this all sounds great, but there is one big, scary monster that haunts every deployment strategy, and it doesn't matter if it's simple or complex, and that is making changes to the database. Here's the core problem. For a short period of time during your deploy, you're going to have both the old version and the new version of your code running at the same time. This means your database schema must be able to support both. So you have to follow some strict rules. Always make your changes backward compatible. A good rule of thumb is to add new columns instead of renaming old ones. Then, you stop using the old column in your code, you deploy that change, and only then, in a separate, later deployment, can you finally get rid of that old column for good.
So, after all this, am I saying that Kubernetes is bad? Absolutely not. The question is all about picking the right tool for the right job and for the scale of your problems. So here's the real takeaway. If you're operating at a global scale, managing dozens of interlocking microservices, or you need really consistent tooling for a massive team, yeah, Kubernetes absolutely earns its keep. It's built for that kind of complexity. But if you're running a handful of web apps and you really value simplicity and predictability, then the ancient ways aren't just an option, they might actually be a much better choice.
And that's really the core message here. These simple, predictable, and rock-solid techniques have been quietly powering production systems for decades for a very good reason. They just work, and they work incredibly well.
So that really leaves us with one final question for you to think about. The next time you're planning a deployment, just ask yourself this. Are you reaching for a giant, complex orchestrator because your problem truly needs it, or just because it's become the default answer? Because a simpler, time-tested way might just be waiting for you.